Hi, everyone. Welcome back to the podcast. Today we have David, the founder of Privasea, and really excited to have you here today,
Thank you so
David.
much. Thank you.
So I guess maybe just to start, could you tell us more about your background and also, yeah, just generally how you came across the FHE space?
Yep, my name is David. My background is more or less in the AI industry before. I've been working quite a few years in autonomous drive, building self-driving cars during 2016 to 2020. Came close with FHE in 2022 because I want to build something conjunction between AI and blockchain. And I feel that privacy computing is very important to bring the data value circulated inside in the public network. That's why I started looking to FHE. Yeah.
Okay, very cool. And I guess like the main topic today is around FHEML, right?
Yeah.
Could you maybe provide your definition of what this is and what this is about?
Yeah. Basically, FHML is for me is like you have productional FHE machine learning pipelines, and basically you have FHE pipelines. It can be applied to the machine learning process, which is make sure when the encrypted data can be used for the inference or the training. And for privacy, we mainly focus on the inference part because right now, I mean, there's a limitation on the training part on FHE for sure. And using either FHE machine learning pipeline to do the prediction or classification as an inference, which is more practical for most of the applications so far.
So maybe for folks who are not machine learning experts, what is an inference? Could you provide an example of,
yeah. So basically, the machine learning process can be divided like two phases. One is you have raw data and you have a calculation pattern, and you want to train this calculation pattern into some kind of model, which is we call so-called training part. And that is the first phase. And the second phase, once you have trained models, and you use the trained models for applications, you host these models and for prediction or classification or data analysis purpose, general, and that is called inference.
Got it. And would it be fair, like an example of an inference is, for example,
Yeah, for example, if you have an image, you want to do the image processing on your face, and then you use a pre-trained model, for example, ResNet 48, that has been trained by you. Then you use that already trained model to do the inference for the face recognition. For example, you use it for to predict the mood or predict sentimental stuff. That is quite common in the current AI applications.
okay.
Yeah.
Got it. So, for example, you can recognize what an image is, right?
Yeah, you can use it for object detection, classification.
Cool.
That's it.
And so maybe to take a step back, what is the problem today that we have with these inference models, and how is FHEML solving this problem?
I mean, for general usage in the Web2 world, I mean, there's no big problems unless you want to have your sensitive data to go public. Then it will comes to privacy concerns, and that's probably the current issues when you, for example, the image contains children faces or any sensitive private information, like in the medical area. You have the patient data. You don't want to go to public, and all data will be constrained in certain areas with the government-controlled environment, and that is hard to share. I mean, the data we generate every day in the real world, the purpose is to use data to generate values to improve our life. But if it's been constrained somewhere, then the data has no value at all. So having a good method, or we call it PAT, privacy enhancing technologies here, I mean, including TE or even MPC or DK or FHE, is all to help him to achieve this, to make sure the data value can be circulated freely in the public network. I think that's the purpose. I mean, which is we want to solve this issue with public data sensitivity.
If I understand correctly, today your sensitive information is circulated in a way that's not safe because other people can see it,
Yeah.
right? But here the idea is that you can encrypt your data,
Yeah.
and people can run models on top of it
Yeah.
in a trustless manner. So
Exactly.
you are solving sort of this trust problem in a way.
Yeah.
Cool. Very cool. Now, I guess to get more into your company, Privasea.
Yeah.
So what is Privasea, if you have maybe a one-liner, but also kind of like what problem is Privasea hoping to solve?
Privacy, more or less, is a public FHE machine learning computation crowdsourcing network, which is we want to create narrative in the deepin plus AI track, which is help people to find the utilities by using our technologies and apply the low-cost version hosting models in a public network.
Okay. And so you mentioned deepin here.
Yeah.
I guess for folks who are not familiar with this term, this is decentralized
physical infrastructure.
And could you maybe explain a little bit how your company is related to deepin?
Yeah. So I mean, deepin is a concept that recently been popular, especially these 2 years.
Yeah.
And but deepin has been in the market for quite long. If you look at the Helium, if you look at some other project, for example, A-Tor, I mean, they've been there for a while, right? And it basically means you're using decentralized physical hardwares to crowdsource some kind of resources. It can be computation resources, can be Wi-Fi resources, can be storage resources like Firecom. So the deepin here is more or less, I would say, is the business transformation in the current industry.
It's some form of decentralized coordination to utilize various resources to achieve some kind of task, right?
Yes.
And then there are other similar companies in the space, for example, like random network for GPU, right? Underutilized GPUs. And I guess now we can maybe dive deeper into like what's sort of the architecture of Privasea and why maybe, is it different from a random network in the context of deepin, right? Like what additional uniqueness or features does your infrastructure offer?
I think render is pretty cool when they use it firstly using decentralized GPU network to crowdsource this rendering power on videos, which is been proved in the market is very uniqueness and a low-cost version compared to centralized cloud, right? And we want to do something similar to random network. So we actually learned quite a lot from their token economics, trying to build something similar. But for us, the difference is we're not diving into just rendering videos. We want to hosting more generalized machine learning models for data analysis purpose or general machine learning purpose. And so we use decentralized, can be GPU, can be CPU, or any other FPGA or ASIC to accelerate FHE machine learning model. And by this crowdsourcing way, which is we can lower down the cost. If we have better designed the token economics, similar like render, then we can lower down the cost and do the data value circulation. And one important thing is the difference is we not using plain text videos or plain text any other materials. We're using encrypted data for the inference. It means the data inside the network is also privacy protected.
Cool. So maybe on that end, could you explain maybe how the different components work? Where is this private model stored? Where is the private data stored? Who provides this private data?
Yeah.
And how does the user maybe interact with your network?
Sure. In general, when the user can be registered as, two sides of the network. One way is from the supply side, and the miner can definitely register as validator or service provider, stake some amount of tokens, and they become eligible, and then they become miners or service provider. They provide hardware, and they get staking reward plus POW reward. The POWs means once they finish some kind of FHE machine learning tasks, they're getting reward after the assignment is done. So this is from supply side. From the demand side is the application. When the application is running and the people pay the gas fee to the network. And from the application side, you basically have to define your calculation patterns. It means you know how this value should be calculated in this network, and then we help you to customize your model and help you to upload it and deploy it in our network. And that whole process is done from the application side. So for us, the network is basically have two parts. One is decentralized nodes, which is we host the FHE machine learning models, and that is off-chain. So all the data processing part is off-chain, and only the token economics part, which actually we formulated into our, we call it so-called Privasea smart contract kit. That part is on-chain, and it can be deployed to any layer 1 or layer 2. And so basically we're like two parts. Yeah.
Got it. And just to make sure I got this right, so you host the private models, your nodes will host the private models, right? And then when they do the computation, they get paid for the work that they do, right?
Yeah, exactly. That's the main idea.
And is there like a use case that you can provide as an example of what kind of model they're storing and what would be like a use case from application but also end user perspective? Yeah.
For example, let's say face recognition. Same. So you have trained your model, which is doing face recognition for public, and you deploy the model to our network first, and now here comes assignments, which is there's 100,000 pictures. It might contain the children faces in the kindergarten, and you don't want it to go public.
Okay.
Then you encrypt the data, send it to our network. So basically, you encrypt the data first and store it somewhere in IPFS addresses.
Okay.
And you just submit these addresses to us. And our nodes will automatically fetch this data from that IPFS addresses and do the FHE machine learning for you. And after the calculation is done, it means the whole FHE machine learning pipeline has goes through all this data, and the result, which is inferred result, which is the name list of all the faces, will be also encrypted, sending back to you. You have your private key because you encrypt your data first with your private key. Then you decrypt the result by your private key and see what is the name list, and only you can do that.
But what do you mean by name list? What's the
name list is actually the face recognition result after the model.
Okay, so in your case, the example that you gave, what was the purpose of this inference? What was the kind of like the purpose of this computation?
Yeah, it's quite a general AI application. Like you want to, if you use a human to do the face recognition, it's basically to save time for tedious work, because then you don't need to use a manual check for pictures, right? It's basically a machine learning generated model to do the face recognition.
Okay, got it. So if I understand correctly, let's say you have a lot of pictures that are the raw data.
Yeah.
You encrypt it.
Yeah.
Then you can use Privasea, some of these predefined encrypted models to run FHEML on top of these encrypted data.
Yeah.
And then the end result is the inference that gets sent back to the original data provider or end user using that private key that you own. You can decrypt and see the results.
Yeah, exactly.
Okay.
And then a more advanced scenario is the data provider knows the result, but he wants to share to someone else in the network.
Okay.
Then use key switching feature to share someone. For example, I want to share the face recognition result to you. I just register your public key into my whitelist. Then you can decrypt by your private key. It's kind of key switching for the calculation result sharing.
Got it. Some kind of re-encryption scheme, essentially.
Similar.
So I know your public key, and I can re-encrypt the end results immediately. Yep. So very similar to how the FHEVM also works.
Yeah, exactly.
As a view function.
Yeah.
Okay. Yeah, very cool. I guess like, what are some of the models that work today with the current state of FHEML? Could you maybe give a few examples of like the models that we can achieve today?
I think there's the general image processing tasks and the general data analysis purpose on financial data or tablet data is quite works quite efficient already.
Okay.
With Zama's concrete ML or TFHRS is I think is applicable for a lot of use cases for now. But there is of course a limitation on the model size.
Okay.
And in general, we have we have like do some internal research on this for quite long, so we know if, for example, if deep learning model more than 100 layers is probably not that efficient yet.
Okay.
Or the parameter number is too big. There are also some restrictions on this, on the size of the model, basically.
Okay.
Yeah.
So based on these current limitations, what's the path of improving these challenges, solving them over time?
I think there's general there are two ways. One is use more powerful hardware, accelerate, like in today's FHE org meeting, we see so many hardware acceleration projects with special ASIC or pre-programmed FPGA. That one way is using hardware to accelerate the process with bigger models, and another way is actually probably take longer because fundamental side on the algorithm improvement or the toolchain improvement that probably even take longer, I think.
Okay, could you maybe elaborate on this second point?
Yeah, I mean, like the schema switch between between models, which is currently I think there's efficient issue to solve it. But I think, I mean, if you look at the papers, recent academic paper, there's quite a lot of discussion on this.
Okay, yeah, that's pretty interesting area.
Yeah.
And now I guess like assuming these challenges would be solved, what would be kind of like the next generation type of models that can be run over FHEML?
I mean,
yeah,
according to Zama, even LM can be applied in some use cases in the next couple of years. I hope that's true. I really hope for.
Yeah, so we can expect maybe ChatGPT.
Yeah, or GPT-like application can be used. I mean, at least for if the generic content is not a really big window, then it probably works, I guess.
Got it. I guess like among, if we fast forward, let's say 3 to 5 years from now, right?
Yeah.
If everything goes well with FHE acceleration, solving some of these inefficiencies, could you paint a picture of what Privasea would look like in this world, and then what sorts of use cases or applications people will use your platform for?
Is it something you mean for the roadmap or?
Just generally, maybe just more on the use case. Like today, for example, what people use Privasea for is going to be very different probably 3 to 5 years from now.
Yeah.
But what are some sorts of like exciting use cases that, or like kind of like the vision that you see with Privasea? Yeah, 3 to 5 years from now.
3, 4 or 5 years later, I think definitely most of the current machine learning model can be applied by this FHE pipeline efficiently, can be used for a lot of applications for both Web 2 and Web 3, especially for where the data is definitely needed, those privacy or compliance, like a medical big data or traditional financial big data.
What would be like a medical big data?
For example, in AI drug discovery, there's a lot of big data needed for, or even synthesis data to be trained in both trained version and inference. Yeah.
So I think earlier you mentioned that today we can mostly do inference with FHEML.
Yeah.
Training is
Yeah.
still complex. So
Yeah.
do you see this problem being solved 3 to 5 years from now? So you can both train and also do inference?
Definitely. Yeah.
Okay.
That's a lot of companies working on this direction,
Yeah.
including Zama.
I guess like in terms of training, there are projects in the blockchain space trying to tackle this federated learning, machine learning kind of like challenge, right?
Mm-hmm.
So curious to know like what you think of how that would look like with Privasea. Do people just help you train models that get paid, or have you thought a little bit more about like what this could potentially look like? Or
It's a good question. Actually, I wouldn't mind to combine with our current network to, for example, federated learning for the training part, because that is more you're building the pipeline for the whole data life cycle, right? You have trained your data, then which is training is definitely a big need in the current market.
Yeah.
So I mean, for sure, federated learning on training data, then you use FHE to the inference, which is more practical at this moment.
Yeah.
Yeah, I think that's a good approach, but it takes time for formulate this data market, because training is not that easy, because the data needs to be clean, it needs to be feature engineered before it goes through pipeline. That's a lot of process, and needs more company working on the tool chain to make that happen. It's not one company or one startup can solve it.
Yeah. So I guess there's a whole process around cleaning up that data that already
because
in
data
Web
is
2.
so many variants on different use cases. It's so hard to have a general version on this.
Yeah.
It's not easy.
But I think what's interesting is like you could use crypto economics to incentivize training, but maybe there are ways you can figure out some kind of...
I've actually seen quite a few projects trying to work on this direction. For example, bagel.net.
Okay.
Yeah, they're trying to formulate a data market on this, and to coordinate different data source, different data owners, and on both training side and inference side, I guess.
Okay.
There's a company working towards on this direction just to build the data market. I think I talked to them before, so I think for privacy is also to cooperate with data market companies to let them to, in a way, to find the correct data purchaser and the data user.
Yeah, I think this marketplace idea definitely makes sense long term. For us, we had a project submit for a hackathon, which is a decentralized federated machine learning project. The way they were thinking about this is that you can train your models off chains. Different participants can train off chain. But they commit back kind of like the new weights of these models. Because these weights are encrypted on the smart contract layer, you could compare and see how far apart they are from each other.
Yep.
And so if they're like a few standard deviation away from each other's answer, then you can implement some kind of slashing, right?
Yeah.
But on the other hand, you cannot copy each other's work neither.
Yeah.
So I do see a lot of potential synergies here between FHEML,
Yeah.
but also kind of like FHE smart contracts as a kind of like a settlement or marketplace layer.
Yeah, that's actually a good example of having FHE applied on the training part, and yeah.
Great. I guess I think we've covered quite a bit today.
Yeah.
I guess your company also recently announced your fundraise. So I guess what's next, right? Like what's upcoming next this year for you guys, also long term, that you would like to share with the audience?
Yeah, we do have a lot of plans on both the network side and the hardware side. Actually, quite a lot of people are interested in becoming our miners, so we plan to have mining ticket sales soon. So building the acceleration hardware using existing technologies from different companies to build the mining machine. That's our probably next step. And we're gonna cooperate with Zama on this. And also we trying to build another application which is on our testnet, which is to let which is the next step for the data analyst to use encrypted data to plot all the data analysis result by using our tool, which is integrated in our network. That's another. I think that's another interesting and exciting product in our network soon, because we want to let data science to really pitch in by using encrypted data in their work to make sure when they do data analysis, there's no privacy concerns.
Interesting. Is there like an example that you can provide?
We could say, I don't know if you guys have heard about Streamlit, which is something we want to build a decentralized Streamlit on encrypted data network.
Streamlit. Okay, I'm not familiar with this company.
Yeah, it's a tool. It's a tool for
Okay.
plotting data analysis result or data science purpose.
Got it. And the goal here, again, is the idea is you could use your platform to plot these, but in a way that only you see the end result, right?
Yeah.
And between
You can share the result inside the tool, the stuff, as long as the guy has a private key. You can see the plot.
Yep.
For example, if you want to do, let's say, New York City housing price prediction on the data set,
Yep.
and you can easily plot in a map with all the housing price by using this tool, and the housing price data, including the user data, will be totally encrypted, and no one else can see the original data, which is probably concern about the user privacy. Yeah.
Yeah, very interesting. So yeah, because this data could be quite sensitive.
Yeah.
Do you see a world where the contributor to this data set, the end users, could also get paid for other people to run models on
Yeah, that's
top?
something we want to integrate with the data market. Then they can define who's gonna pay for this data or who's gonna pay for this model.
Yeah.
That's something. That's why we want to cooperate with data market projects, which is we want to be the protocol, and the market let someone else to do it.
Yeah, this is a very interesting idea because it's almost like if you can have a middle layer similar to like Plaid for financial data, but this Plaid is fully encrypted.
Yeah.
But people can do compute on top of it, but they're willing to pay you for this type of data, right?
Yeah.
So like in today's world, a lot of hedge funds or institutions will pay for, let's say, credit card purchase histories, right?
Yeah.
Because they want to be able to make predictions.
Yeah.
And they're also willing to pay money for it, right? So
yeah, exactly. That's the data purchaser and the data owner's relation. And for us, our business model is quite simple. We don't care how much they pay each other, and we only take part of a gas fee if they're gonna use our network to do the FHE machine learning.
Got it. So if I understand correctly, Privasea today, you can host private models, you can do compute on top of it.
Yeah.
In the future, you will also allow for, training directly over FHE.
Yeah.
And then you're also working towards this kind of like broader vision of some kind of marketplace, aligning interests from different parties over time.
Yeah, that's correct.
Cool. And I guess what's your rough timeline for like, let's say a testnet and a mainnet?
Testnet will be second version. We will have like a simplified version of this so-called encrypted streamlit in Q2 or latest Q3 this year.
Okay.
And mainnet we will launch on Q4.
Okay. And then I guess today, if anyone wants to try out your platform, is there anything they can do?
Yeah, basically we have 4 default machine learning models being deployed in our network. Anyone can just put in our Docker and try with command line. So there is no visualized version yet before we have this streamlit stuff. And then you can test it by yourself to see those 4 machine learning models, how that works with FHE pipelines. And for example, there is a breast cancer prediction model you can try out to see how this prediction can be done by this different the open data set, which has been in our website. You can just test it the X side and to see what is the result on the Y side.
Interesting. So you can submit your maybe like, is it like a scan, X-ray scan, or like what's the input?
I mean, for the user, it's hard for them to provide original data. We already provide the open data set, which is they can directly test it.
Okay, interesting. So they can, using their own personal data, interact with this data set.
Yeah, they can do that.
And then see if they have breast cancer, basically.
Exactly, yeah.
Okay, very cool.